Good afternoon. I hope you are enjoying the Linaro Connect and have attended quite a few presentations and discussions. So, myself, Yogesh Deshpande, and I work in Architecture and Technology Group in ARM. And this is a joint presentation between me and Julian, but Julian was also supposed to be here, but he is having some medical conditions, so it's me only presenting today. Before I start my presentation, I just wanted to check with the audience, did they attended the keynote from Grant Likely yesterday? Anyone? Did they talk about EUCRA and did it resonated well with the audience, I suppose? And there was a presentation from AdLink today about highlighting how CRA is heading towards. So I'm just going to start with the first slide. What exactly is being asked in EU CRA? CRA stands for Cyber Resilience Act. It's been actually, it started off in 2022 and became a formal act in October 2024. So basically it is setting this platform for meeting the security by design. So you have to follow security principles from right from the inception of your product design, product architecture, all the way throughout the life cycle of your product. So why do we need this kind of a regulation? Because otherwise the security ecosystem would be fragmented. Vendor X will do security in a certain way, vendor Y will do security in certain way, and it becomes hard for interoperability and setting a particular benchmark for security. So effectively, CRA aims to address that problem, and that's why they bring it into force. And every vendor, whether it is any vendor which is generating an open source, has to comply if that open source is utilized for a business purpose. So every open source software or open source hardware which is used in for business purposes needs to comply with CRA by the end of 2027. That's the deadline. And that's basically done to protect the consumers and businesses, because electronic equipments are with the software and the firmware is going in all types of products are made, whether it is critical medical applications to automotive and everything, all the needs. So basically, let us look into what exactly are these regulations. So as I mentioned earlier, that the technical documentation needs to be done, how you are protecting your keys, what is your threat model, what security principles have you followed, and have you done secure integration of OSS components? Meaning what? Do you have secure builds? Do you sign the builds? Do you have proper integration test? Do you have system integration? Do you have a security test? Do you do fixed linting? Do you do code review? All that part falls under the secure integration and secure release of OSS components. Now the third is the vulnerability management. So how do you, once you release, have you done the vulnerability scanning? Even it is on the product, let's assume that the device is having the firmware running in the field. Does the vulnerability appears? Are you tracking that vulnerability? If there is a vulnerability, what is the plan to fix it? Are there any policies in place that you will fix the critical vulnerability in a certain period of time? It's 3 days or 5 days, that those kind of things. And the transparency is very important aspect of UCRA, which I will talk about a bit more into details. And the last and the most important point is, if you don't follow these regulations, there is a cost implications. So there could be fines implied onto your business. So now coming back to how we as ARM deliver today the software. So a platform integrator just gets software, firmware, and makes a custom firmware integration. Means it forks, it adds its own configuration, it adds its own features. It may have certain practices, like it may do secure boot, may not do secure boot. All those kind of customizations you have, n number of images and n number of flavors of the coming from the same root. That's a problem. And often that firmware is maintained by the SOC provider and it's internalized. And the firmware component is not often up to date. Once it's gone, there is no update path, there is no update commitment, or there is no proper life cycle tag to it. And there is no firmware composition attached to it, like how it has been built. Is there a provenance story behind that firmware? We don't have it today. What about the vulnerability status for firmware and hardware vulnerabilities? We don't have that today. And then we don't have a release schedule that this is only applicable for 1 year and we'll have another revision much more better, or any new revisions. We don't have the commitment, or if the CVEs are detected, what is the response mechanism? So these are the challenges which the platform integrator faces when taking the firmware from the upstream suppliers. So what should we be doing to make this ecosystem into the right order? So we need to put the upstream suppliers to have more reliance to meet the CRA obligations. Effectively, that means we use standard pre-built images which is signed and have provenance metadata. I will talk a bit more in detail about what exactly provenance metadata means here. And we need more transparency on release schedules and support periods, how long we are going to support this firmware or hardware revision, and what would be the roadmap for things coming next. And as I already touched upon, the secure software processes throughout the life cycle of the product or the software. And auditability is the very critical thing. Like independent auditors should be able to audit our release processes, our deliverables and stuff like that. We need to set up a vulnerability management process into the mix. And if you have multiple revisions or multiple flavors of the same image, then it becomes very complicated for the software supply chain. So we need just we need to, and more supply chain complexity means more cost for compliance, because n number of build flavors means management cost overhead increases significantly. So we need to improve this situation. So effectively, if we look at today, we can kind of this is kind of sectionalizing certain software into layers coming from the different types of suppliers. So like we have a hardware layer coming from the SOC board, the boot layer. We have like the trusted firmware A, hafnium and RAC layers, the TPM 2.0 and secure storage are just an examples of the base trusted services layer. Then of course we have the trusted OS, the Opti and the TE. Then on top is the UEFI, and then there are certain individual customizations done through the device tree config. So this is kind of an abstraction of layered models where we have assigned kind of individual layer to the source of the suppliers setting this scene. But we don't have a formal definition of platform integration as of today. So we don't have a formal definition like this. So if we want to kind of address the new requirements, what exactly we need to do if you want to comply with CRA? So we need to make sure that we have the software bill of materials which define the composition of the firmware. As well, we need a hardware bill of materials. And the reason CRA doesn't directly say hardware bill of material, but it tells you to describe the it tells you to manage the hardware vulnerabilities. And once you start using reporting hardware vulnerabilities, that comes to hardware composition. Effectively, that links to hardware bill of materials. Then the assurance metadata is what level of security assurance you have, like what I will talk a bit about what are the assurance levels in the subsequent slides. But how you have composed your firmware, and are you following any standard for expressing the composition of the firmware? And we have been looking at what is the best way of expressing the firmware composition, and what is the best way of distributing firmware as well as the artifacts. So here artifact means the associated metadata, which means provenance metadata, the signing infrastructure, and all the provenance information that is attached to the firmware. At the same time, the signing infrastructure, how we sign the key, what are the keys, and how the keys should be revoked, or how the keys should be rekeying when the certificate expires, and all those kind of things. The key management and tooling. And vulnerability management, I kind of touched at length. And the compliance automation is continuous compliance through the running of set of tests in an integrated manner, and then producing those in a transparent manner. So we have been looking at what are the existing open source standards we can borrow to meet the CRA obligations, and OpenSSF has the best security practices going forward. And of course the standard SBOM formats, SPDX and Cyclone DX, can be utilized to express the software bill of material as well as hardware bill of materials. The SALSA framework talks about SALSA security levels, where security level 0 is no security, but level 1 you have some kind of provenance metadata, but it is just self-certification from the supplier. Level 2 adds some signing on to the provenance metadata, and level 3 talks about reproducible builds, and those are perfectly aligned with the CRA requirements of Azure risk-based as conformity assessments. So we have been looking into that. Another point is how do you make these things available for independent auditors, and how you do it in a transparent manner. So Six Story, a very perfect example, is doing that thing in a transparent manner, where you put your stuff into an append only log, essentially a ledger, where you can't, once you have made a statement from a designated authority, it cannot repudiate the statement. So it's known in the ecosystem that you have made this commitment, and it's been audited by independent auditors. So that's the kind of thing which is precisely CRA is looking at. And of course you will have a vulnerability story, how you report it, what is your patching mechanism, what is the policies behind your vulnerability management. And for distributing the firmware and the provenance metadata, we are looking at evaluating the OCI artifact specification and OCI distribution specification. And if need be, we will look at even more existing standards that fits in with the kind of deliverables we do from ARM, like hardware and firmware. So this is how we see, this is the kind of model we look forward going forward, which I believe is an abstraction which we are looking into. This is not like a final picture, but this is, we think, is a possible option for doing that. So at the bottom is the board supplier, who is supplying the hardware. So you have the provenance metadata associated with the hardware and the hardware bill of material, and the signature putting the commitment behind who is delivering this. And on top is the number of firmware which we discussed in the previous slides. So these are n number of firmwares coming in along, which has images, provenance attached to the firmware, the software bill of materials, and the signatures produced by the individual authorities who are responsible for those firmware. And each of these are pushed into their own artifact registry. And then a platform integrator takes all those stuff, and the platform integrator's job is to integrate that stuff, and it creates a platform manifest, and then it signs that platform manifest, and it goes into a CI/CD pipeline, where it gets properly integrated. A series of tests are run: compliance test, system ready test, PSA test, whatever the test regime happens. And at that CI/CD you can do the checking, whatever checking you want to do. You want to do the signing checks, whether the images are signed properly by the right signers, and you can verify the provenance. You can do some kind of scanning like malware scans, vulnerability scans. You can run all the tests, and when you do these, it does generate a lot of data, like the compliance reports will be generated when you run the compliance test. uh, you might want to capture the measurements of the individual binaries, so that when you do the dynamic runtime attestation, these measurements can be provisioned into an attestation verifier, so that you can do the remote attestation. And all this data needs to go into a transparency log, obviously, because then those commitments you cannot backtrack. And in the ecosystem, many auditors in the community can do the auditing, and that's what exactly CR is looking for. And the way the OneLab is set up at the moment, OneLab is perfectly suited to kind of upskill itself to perform this role. And we have been in discussion with OneLab to kind of precisely address how we can upscale OneLab, because it's already doing the system ready test, and it is a platform where the hardware and different type of combination of software, firmware from ARM and different OS vendors come along and do the compliance testing, so that they are assured that everything works very well on ARM platform. So that's where it's perfectly suited. So that's what I just mentioned. Its collaboration is happening with Linaro. on the one lab initiative. The first 3 bullets is already been taken care of by one lab. So it's a trusted ecosystem resource for verifying ARM firmware compatibility across different OS and middleware. And it has a lot of automated tests which runs on the real target hardware with different types of flavors, whether it's in a Linux or Windows on ARM platform. Mm, and it is an independent lab, so it is audited in a community fashion. So it needs to be, the last 2 bullets shows that it needs to be upgraded. The continuous compliance fits very well with the CRA compliance requirement, and so we are collaborating with Linaro to extend the capabilities to help producing product manufacturers meet CRA obligations. So these are the goals which we aim to achieve in this coming, before the CRA timeline expires in December 2027. So provide a blueprint for automating the compliance and avoid adoption barriers, so that the standard practices and existing tooling can be reused for multiple platforms rather than reinventing the same things again with multiple folks. And then that's what is promoting the supply chain interoperability. And as I mentioned, reusing based on pre-built images is greatly going to help the ecosystem. And for that we will extend one lab to provide flagship deployment for showcasing continuous compliance measures that can be integrated into production CI/CD pipelines. Yeah. So yeah, I think that's all about it. If anyone is happy, we are happy to invite contributions from outside community as well. It's not just ARM and Linaro, but it's a community effort. So anyone who wants to join hands are welcome. Yeah. Any questions, please? Yeah. Yes, Manish.
So I haven't attended grants yesterday's talk.
Okay.
But this law, is it just for open source projects, or it is?
No,
because you mentioned open source projects.
I stressed predominantly open source because we we as ARM operate in open source, and we are targeting this, but it is equally applicable to all products which are making business actually.
Yeah, that makes sense. Otherwise,
yes,
just to comment, I'd say you've got SBOMs and HBOMs. Realistically, we need to start thinking of these things as BOM elements.
Yeah.
And put them into databases, because the piece that you're missing on that set is the data sets. And as we're going to AI and training, we're going to have transparency there that's going to have to eventually be included in part of this story. So there's a lot of things that, like I said, so BOM elements, and using the term BOM is probably going to be the most future-proof term we can work with right now. But better ideas are welcome.
Yeah, I mean, when I'm expressed composition, effectively you need to link in the platform. You need to link. You need to create a tree structure.
That's right.
And that tree structure has to go in a transparency log where everybody can see what is your tree structure, how you have followed security in building from bottom up, actually.
Yeah, and so like in SPDX, we have a knowledge graph capability where you have the elements and you have a whole bunch of relationships to show how they relate to each other. So leveraging some of that to explain this and put this into the tooling right now, so we can get this exported out automatically, I think is our only path to sanity in this realm. So happy to have more discussions about it, because I think we need to get there. And the other thing I'll say is there is a working group in SPDX on the hardware bill of materials that's looking at physical as well as virtual. And then we're also looking at the safety case. So we would welcome your input, especially on the firmware and how you want to basically have some of the aspects of the SoCs, the silicon, and so forth represented to make sure we're doing it right, so that we can eventually get this all linked up properly.
Absolutely. I think I attended few of your meetings in Linux Foundation last year.
Okay.
And then I think with this new initiative, I think we'll have to engage more with.
So Friday mornings, North American time, afternoons this time. 8 a.m. So happy to, anyone interested in the coordinates, let me know. The other thing to watch out for is we have a shifting definition of BOMs or SBOMs. The US definition has shifted a bit. The version 3 of the framing document shifted. That's different than the EU CRA Act. The EU CRA Act is likely to be coming off of something out of Germany and a set of host days, which is a different set of fields. and we've got a different set of fields showing up in India.
Mhm.
So being flexible with our language and catching as much data as we can so that we can react to that is probably going to be a factor as well.
Yes, I mean, it's interesting question because when the CRA initially set out in 23, 24, maybe I think the first revision they will be a bit relaxed in 27. I'm assuming that there should be some degree of composition expression and linkage expression. They can't be so hard tight bound that you
Yeah.
have to be the latest of the version of SBOM you are presenting into. I
Yeah.
find it hard to understand if they can be that tight.
One of the things that the Japanese have done is they've used the SPDX Lite, which you can actually fill in a spreadsheet format.
Oh,
And then you can, so your very small suppliers and things like that that don't have a lot of infrastructure, but at least you don't get garbage coming into your system where people are guessing.
Yeah.
So the companies that are providing things that are small and can't be fit into a big framework can at least give you enough data to start with.
Yeah.
And Honda gave a pretty good talk about 2 months ago now about their whole entire supply chain for automotive. And 59% of their supply chain is open source. Their slides are available publicly. I'm happy to point you at them afterwards.
Yeah.
But you can sort of see that we're going to have to pull all these pieces together because we know that hardware and software are going to interact. But I also say that hardware, software, and data are going to be interacting in the future.
absolutely. I attended your talk yesterday, the keynote. Yeah.
Okay. But
Thank
like I say, I've got a lot more data, so happy to talk more later. Thanks.
Manish, you have more questions? Yes, please.
So you told us about how one lab could help with the compliance effort, if I understood correctly. Then in that picture, do you, in your mind, is keeping track of the vulnerabilities, for example, part of what one lab could do? Taking the inputs regarding, for example, published CVEs, linking those to the SBOM, making you aware when your firmware is ultimately found to have those vulnerabilities.
Exactly. Yes,
Okay.
that's exactly this bit, the vulnerability scan. So one lab can take the scanning of vulnerabilities, and if found, we can fix it there itself. But it may be possible that this goes out, right? The distributor sends the firmware, and later it is detected. So what they want to see is that what is your policy if some critical vulnerability is reported. I think they have a strict policy like you have to fix it in 3 days or 5 days. So there should be a process in place. They want to see that what if it is detected, what is your policy of handling that, and how would you mitigate that. So that kind of thing has to be documented, and then there should be practices in place to implement that.
Okay, and that, okay, so I missed the vulnerability scan bit. That's why now I understand. Thanks. And does that even mean keeping track of all the past releases that you have done, and not only the latest one you are working on in your CI/CD? Then do you
Yes,
need to keep track of the full history of SBOMs?
Yes, effectively, because more to that, it will keep archiving. So you have, let's say you started with 1.0 in, then let's assume in 6 months time or 1 year, you have 2.0, then you need to keep retaining some information about 1.0 and say that, hey, now it's 2.0, you should all move to 2.0, something like that. But yes, it has to be incremental, but the life cycle has to be fully supportive. Or let's assume that say, hey, from 6 months onwards, please don't use this because this is going to be obsolete. Use this one. That kind of direction also should be documented.
Okay, thanks.
Any other questions? Well, then, thank you so much. It was great interacting with you. Thank you so much.